Motion flow is a modular motion fields or a motion matching system that allows you to jump arbitrarily in your animation database at any point to produce smooth transitions that it produces responsive character control. In order to do that, we define a concept of a constraint, which is a feature vector generator. So let's look at an example of locomotion constraint. So as we know that for locomotion, to perform a motion matching query on it, we would need three components. One of them is the pose, one of them is the past trajectory, and one of them is a future trajectory. So here we can see that the constraint locomotion is comprised of three fragments, which are all feature vector generators. And one of them is the pose, one of them is trajectory, which we have provided a negative delta time that ultimately results in a past trajectory and behavior, and then a warping trajectory, which is a future trajectory predictor, which also warped towards the direction that you want to go. So using these three fragments that you define the feature vector generation behavior for locomotion. Similarly, for interaction with the environment, for something like using a switch, you would also have various fragments comprising of the constraint. So here we have a pose fragment, a trajectory fragment, and instead of a warping trajectory fragment like locomotion, this time we have distance fragment, which measures the distance and the angle of approach to a desired task. For example, in this case, the switch that you want to turn on. And each of these fragments is also editable, so you can go and modify various weights. For example, for this distance constraint, you can modify the weighting between the angle and the distance, and the debug draw color for various things. And speaking of debug draw, each of these fragments also provide its own debug draw functionality, which is overridable in C++, and you can then bring in constraints as you're performing your searches. So for example, you're transitioning from locomotion to turning a switch on, then the fragments get swapped in and swapped out, and then ultimately the debug does the same. So the debug gets handled in a modular fashion as well, which I'll demonstrate a bit in the next few videos. So now that we understand a bit of what a constraint comprises, let's look at how we can use a constraint to annotate our animation database. So let's look at a simple locomotion animation. So maybe let's look at our combat jog reposition 1, which basically is a character just using a combat jog style and performing various kinds of repositions. So here you will see that we have marked the entire motion set as a single task, and then the advantage of doing this is that you can leave out, like for example, the character going from T-pose to a starting point, so that part of the animation is not included in feature vector generation or matching. And now this notify itself is marked with the constraint locomotion over here. So this is how you annotate a locomotion task. And similarly, now let's look at something like a switch. So if you open the switch, now this has a bit more annotation because we need to specify a few things here. So let's zoom in on one such set. So in order to understand this better, I'm going to disable the root motion, enable root motion checkbox so that we can see the character moving in the world. So here you see that we have started saying that the character is entering switch here, and then it performs the switch action here, and it finishes over here. This task search within this notify is actually the point where you can jump into this animation segment, and this is actually where the search itself is performed. The contact is the point where you want to stop your warp or you want to finish your warp when this point happens. On this we have used the left foot contact on the ground, saying that don't warp beyond this point. And then ultimately this notify over here says that this task is finished, and then you can use various systems that I'll describe in the following videos to connect or do other things based on the event generated by this notify. So one thing you could do, for example, is the task falling right after here where the character leaves. So you'll see that the first task here was marked as a constraint switch constraint class, And then the second task over here, where the character is leaving, is marked with switch exits, which is a different constraint that we have created and that you can use to annotate by using this drop down over here. So this is how you annotate your motion data. I'm going to re-enable the root motion and save this. So now that we have annotated or understood how to annotate our animation, these animations need to be collected together into a data set, that data asset that is ultimately used by the motion flow system to build a database of feature vectors. So here we have all the animations listed out that we have annotated. So there's kind of combat jog, locomotions, and vaulting animation, switch, using the switch, going into cover. These are the examples that we are currently using in this motion data asset. And you can generate the feature vectors by clicking this button or clicking save, which also generates the feature vector and saves it within the motion data asset, so that the data asset can then be queried for feature vectors during runtime. So now you would also need a blueprint that connects all these together, connects the user input, the motion data asset, the motion flow system, along with the animation blueprint, which I'm going to discuss a bit more in the following videos. But assuming we have done all that, then what you can do is basically use, in this case, keyboard input to provide input to the character, which ultimately provides input to the constraint fragment to generate feature vectors, which picks the appropriate animation from the motion database to produce the desired result. And for example, now I've been making the character go left and right. Now I make him go closer to this place and then press F. That asks the character to hit the switch button, so you can see that the character performs those actions. I can approach from a different angle and it will use a different entry into that switch. And this time I asked the character to exit on the right, and that's why I did that. So since we were mentioning debug before, I'm going to enable the debug draw. That is by hitting the colon key or the code key on the keyboard. So that enables the debug draw. And on the left, if I slow down the animation, then you can see that on the left various constraints are printing their own debug information. They're also performing the debug draws in the world. And as I make my animation faster again and hit F, and then you can see that once you start performing the dock, then the debug draw also should change. So this is ultimately the motion flow system at a high level. I'm gonna talk a bit more about a few more features in follow-up videos, where I'll dive into things like debug draw or debug using Visual Logger, a bit more about the anim graph and the blueprint setup, and a few specific demos that you can explore to understand how various things are set up. Thank you.